For part A, net torque is equal to 0 because the only force acting on it is force of gravity, but it's acting on the center, so that there's no torque because there needs to be a radius. Because net torque is 0, the change in angular momentum is 0. So that means angular momentum is conserved. We can expand this out to CPR. The linear momentum is at the perigee and R perigee. And then for the right side, it'll be linear momentum at the apogee and that'll be R apogee. The C cancels out and you can expand linear momentum at the perigee to the MVP. And the same for the right side, but VA. Mass cancels out because they're the same mass. And that's our equation for conservation of angular momentum. For B, mechanical energy is conserved because no energy is being added or taken away in the system because there's no external forces. Because of that, MEI is equal to MEF. MEI, which is at the perigee, has kinetic energy and potential energy. And at the apogee, it also has kinetic energy and potential energy. We can expand this. And our focus is the sun. The mass of the comet cancels out. And that's our equation for B. For C, I'm going to use the equation we just had for part B. So what I'm gonna do is, since I see that RA and VA are at the denominator, I'm gonna multiply the right term, which is this thing, by VA. And I'm gonna replace RP using this thing right here. So I'm gonna isolate RP because that's what we're trying to get rid of. And I'm gonna insert it into here. I'm gonna move this thing to over here and moving this thing over here. On the right side, I can factor out G m of the sun over VA RA. And for the right side, I can factor out A 1/2. VP squared minus VA squared can be expanded. Now I can cancel out VP minus VA. And I can move the 2 over to the other side. And then I can move VA to the other side too. So that'll leave me with the proof that VP is equal to that thing. For D, I would set up the conservation of angular momentum again, and that'll let me find the ratio between their velocities. So I'm gonna isolate for VP. The RA is 6.1 times 10 to the power of 11, and RP is 5.1 times 10 to the power of 10. So that would give me 11.96 VA is equal to VP. I can use this function now. So 11.986. I'll move the VA from the right side to the left side. And I'll multiply VA by both sides so I can move the VA at the bottom over to the left side. Things on the right side are all constant. So I can plug in the numbers. And I'm gonna move the 12.96 to the bottom. And I'm gonna square root both sides. So that's my velocity at the apogee. And for the velocity at the perigee, I can just use the ratio that I found over at this part. And I can simply just plug it in. So these are my speeds. For part E, I can set up E total or mechanical energy is equal to K plus U. I can expand K into 1/2 mv squared and U to be negative G mm over R. Because it's an ellipse, the total energy would be negative G mm over 2A. The mass of the comet cancels out. I'm gonna move the GMS over R to the left side. And I'm gonna multiply both sides by 2. So this will have a 2, and this will be gone. Then I'm gonna square root both sides. I'm gonna factor out the GMS so it'll look like the function inside it. And that's the general form. For F, now the comet is in a circular orbit and its radius is equal to the distance at the perigee. So because it's in a circular orbit, we can use V orb equal to GMS over R. And we can get that by saying FC equals to FQ together. And then MV over R is equal to R squared. Or 1 over R squared times G mm. The M cancels out, and the R also cancels out. And you can square root it both sides. And that's how you get that function. And all we need to do is plug in the numbers. In the original elliptical orbit, its VP is 69,479, but in the circular orbit, it's only 51,143. And because of that, the velocity is is less than or slower than the velocity at the original elliptic orbit at the perigee.